I am Prasannanjaneya Reddy, working as Assistant Professor in the Department of ECE, Institute of Aeronautical Engineering College, Dundigal, Hyderabad. In this session, we are going to discuss about non-preemptive multitasking priority-based scheduling algorithm. Non-preemptive means the process is scheduled for execution after completion of the currently executing task only. Priority means while task is created or process is created, we are assigning the priorities based on the requirement. Reset is highest priority, or power or low power, zero power means that is also highest priority. Like we are assigning priority 1, priority 2, priority 3, priority 4, like that. So among them, so 0 means highest priority or 4 is highest priority, that is defined. Based on that, we can schedule the process. Which process is scheduled for execution? So non-preemptive scheduling. Once complete the currently executing task, then only a new process in the ready state is scheduled for execution by the scheduler. Priority, based on the task, whenever it is created, we are assigning priorities. First priority, second priority, third priority. 1 is the highest priority, 3 is the somewhat low priority, like that, when comparing with 1. Shall we go with one example? So here we are considering 3 processes, P1, P2, P3. With estimated execution time 10, 5, 7 milliseconds. And priorities 0, 3, 2. Here 0 is the highest priority, 3 is the lowest priority. Respectively, enters the ready queue together. At the same time, these 3 are entered into the ready state. So, calculate the waiting time and turnaround time for each process, as well as calculate the average waiting time and average turnaround time of this requirement. Let us consider no process is waiting for either input data or output data. So here we are following priority based scheduling algorithm. So shall we write like this for understanding purpose? So 3 processes with process ID is P1, P2, P3 with estimated execution time 10 milliseconds, 5 milliseconds and 7 milliseconds. And the process P1 priority is 0, P2 priority is 3, P3 priority is 2. Here 0 is the highest priority, 3 is the lowest priority. as per this definition, as per this requirement. So we need to calculate average waiting time and average turnaround time. So you can take timing diagram. So at the time of 0, what are the processes available in the ready state? P1, P2, P3. So scheduler checks the ready state, what are the processes available in the ready state and which one is scheduled for execution as per scheduling algorithm. Here scheduling algorithm is priority based scheduling. So among these three, which process is having highest priority? So P1 is having highest priority. So P1 is scheduled for execution first. Since it is non-preemptive, after completion of P1, then only the scheduler checks the ready state to schedule the processes. So P1 execution time is 10 milliseconds. Again, so P1 enter into the running state and after completion, completed state. Okay. Now P1 is completed. Again, what are the remaining processes available in the ready state? P2 and P3. Among them, which process is having highest priority? So P3 is having highest priority. So P3 is scheduled for execution at the time of 10th millisecond. Since it is non-preemptive, after completion of P3, then only a new process is scheduled for execution. So P3 execution time is 7 milliseconds. So 70. Again, we will check. P3 is completed. It is come to the completed state. Okay. Next, in the ready state, what are the processes available? P2 only. So that is P2 is scheduled for execution. Its execution time is 5 milliseconds. So 22 milliseconds. Now calculate the waiting time for process P1. P1 is entered into the ready state at the time of 0 and it is scheduled for execution at the time of 0. So its waiting time is 0 milliseconds. Next, waiting time for process P2. Process P2 enter into the ready state at the time of 0 and it is scheduled for execution at the time of 17th millisecond. So 0 to 17 millisecond. It is waiting in the ready state to get the CPU. So 17 milliseconds. Next, waiting time for process P3. Process P3 enter into the ready state at the time of 0 and it is scheduled for execution at the time of 10th millisecond. So it is waiting 10 milliseconds in the ready state. Average waiting time is equal to sum of all these waiting times by total number of processes. So for this requirement, if you are following the priority based scheduling algorithm, The average waiting time is 9 milliseconds. Now calculate the turnaround time for process P1. So P1 is entered into the ready state at the time of 0 and its execution is completed at the time of 10th millisecond. So total turnaround time is 10 milliseconds. Next, turnaround time for process P2. Process P2 enter into the ready state at the time of 0. Its execution is completed at the time of 22 milliseconds. Total time is 22 milliseconds. So, process P3 is entered into the ready state at the time of 0 and its execution is completed at the time of 17th millisecond. So, turnaround time is 17 milliseconds. So, average turnaround time for this requirement is sum of all these times by So for this requirement, if you are following priority based scheduling algorithm, the average turnaround time is 16.34 milliseconds. Shall we take one more example? Again, I am taking one more example. 3 processes P1, P2, P3 with estimated execution time 10 milliseconds, 5 milliseconds and 7 milliseconds and priorities 0, 3, 2. If a new process, let us consider a new process P4 with execution time 2 milliseconds and priority 1. Enter into the ready state after 2 milliseconds of execution. Whatever the process scheduled, once execution started after 2 milliseconds, a new process P4 entered with priority 1. Here 0 is the highest priority. Three is the lowest priority. So by using non-preemptive priority based scheduling, calculate average waiting time and average turnaround time. Let us consider no process is waiting for input data or output data. Okay, in that point of view, calculate that one. So okay. So at the time of 0, what are the processes which are available in the ready state? P1, P2, P3. We are following non-preemptive priority-based scheduling algorithm. So among these three processes, which process is having highest priority? So P1 is having highest priority. So that is scheduled for execution. So P1 enter into the running state. Since it is non-preemptive, once complete the P1, then only a new process is scheduled for execution. Okay, so its execution time is 10 milliseconds. So in this meanwhile, at the time of second millisecond, P4 enter into the ready state. Okay. At the time of 10th millisecond, what are the processes available in the ready state? P2, P3, P4. Among them, which process is having highest priority? P4, that is first priority. So that is scheduled for execution. Since it is non-preemptive, after completion of P4, then only that is scheduled. Next. Its execution time 2 milliseconds. Next, at the time of 12th millisecond, what are the processes available in the ready state? P2 and P3. So among them, which one is highest priority? P3 is having highest priority. Means P3 is having highest priority. Then, at the time of 90th millisecond, here P3 is completed. It is entered into the completed state. Okay. Now, what are the processes available? PT is only available, so that is scheduled for execution. Its execution time is 5 milliseconds. So that is 90 plus 5, 24 milliseconds. Now, calculate the waiting time for process P1. So, process P1 enter into the ready state at the time of 0 and it is scheduled for execution at the time of 0 itself. So, immediately that is scheduled for execution. So, waiting time is 0 milliseconds. Next, waiting time for process P2. Process P2 is entered into the ready state at the time of 0th millisecond and its execution is scheduled for execution at the time of 19th millisecond. So it is waiting 19 milliseconds in the ready state to get the CPU. Next, waiting time for process P3. P3 is entered into the ready state at the time of 0 and it is scheduled for execution at the time of 12th millisecond. So it is waiting 12 milliseconds in the ready state to get the CPU. Next, waiting time for process P4. Process P4 enter into the ready state at the time of 2nd millisecond and it is scheduled for execution at the time of 10th millisecond. So it is waiting 8 milliseconds in the ready state to get the CPU for doing its operation. So now the average waiting time is equal to sum of all these waiting times by number of processes. That is equal to (9.75 milliseconds). For this requirement, if you are following this non-preemptive priority scheduling, the average waiting time for each process is 9.75 milliseconds. Now calculate turnaround time for process P1. Process P1 enter into the ready state at the time of 0 and its execution is completed at the time of 10th millisecond. So total time taken by the process P1 for completion of its execution is 10 milliseconds. Next, turnaround time for process P2. Process P2 is entered into the ready state at the time of 0 and its execution is completed at the time of 24th millisecond. So total time taken by the process P2 for completion of its execution is 24 milliseconds. Next for P3. So process P3 enter into the ready state at the time of 0 and its execution is completed at the time of 19th millisecond. Means total turnaround time is 19 milliseconds. Next, turnaround time for process P4, that is equal to, so process P4 enter into the ready state at the time of 2nd millisecond and its execution is completed at the time of 12th millisecond. So the time taken by the process P4 for completing its execution is 10 milliseconds. So average turnaround time for this requirement is average turnaround time for this requirement is 15.75 milliseconds if you are following the non-preemptive priority based scheduling algorithm. So like this, so we can check that requirement in non-preemptive priority based scheduling algorithm. How much time it will take, how much time it is waiting for the CPU. So for this topic, we can refer the textbook is Introduction to Embedded Systems by Shibu KV, published by the Tata McGraw-Hill Company. That is 2nd edition, 2009 published. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.